first look at the limits and their properties, the limits of the function. So what are we going to do? The limit means we are going to find the function values, right?
Right.
When x approaches to a value, to a particular value, to a fixed value. Okay, so our task is to find the function value when x approaches to some, the fixed number. So in notation wise, we use that as this one. Suppose if your function f, okay, with the variable x, if your function fx is given, right, or defined in a particular interval, the limit of that function when x approaches to the value a, we write, if this is, happen, then we write that as the real value L. Okay, so L is a real number. So it is understandable by looking at the notation that the function is getting the value L when x approaches to a. If you draw a real line, your x is coming from the real value, real line. Okay, 0 is somewhere here. So your x real number may be negative, okay, may be positive, but for example, say a is say 1. That means if you want to look at the function value when x approaches to 1, this could be done in two different directions, right? So your x value may approach from the right to 1 or from the left to 1. So when you are asked to find the limit, you have to understand that we are finding the limit value in both the directions. So the x value is approaching to a from the right and left as well. Okay, so if you could find, a common value for both directions, then we say that the limit exists, right? So look at this given example. So the question is now, here in this table, we are going to find out what's happening to the function fx when x approaches to 1. As I said earlier, in your real line, 0 is here, 1 is here. So we are looking at in both direction, okay? So in this type of methods, finding the limit values by making a table is called what? If you look at here, it is called the numerical, right? The numerical method means you are plugging some possible x values very close to 1, okay? So I am picking some values, right? Remember 1 is here. From the left side, you have to pick some real numbers which is very close to 1 but in left direction, okay? Therefore, you have to pick some numbers which are smaller than 1. Remember, this side are smaller than 1 and the right side is bigger than 1. So I'm just simply plugging some number very close to 1, 0.999, 0.99, 0.9, 0.75. Then we are picking some numbers in the right direction of 1, very close to 1, 1.001, 1.01. And we are checking what's happening to the function. Remember, my function is here x cubed minus 1 over x minus 1. Okay, so we are finding the limiting value. So this table will give you some idea, right? So when x goes to very close to 1, what will happen with my function value? What is your conclusion by looking at the table?
That it's going to be very close to 3,
Exactly.
if not 3.
Exactly. The function is getting very close to 3 when you approach to 1 because these two numbers are very close to 3. Okay, so we just simply guess, guessing and plugging the values. So they say that limit approaches, the limit value of the function is 3 when x approaches 1. Okay. So this is about the numerical method to find out the limit value of a given function. This method is always going to be, lengthy procedure, right? You need to plug in so many values and checking, but this is obvious. So you could guess the answer. The second one, the second method we called, if you look at the picture and, finding the limit value of the function, which is called the graphical method to find out the limits. Okay. So if you are asked to find the limit value graphically, that means you have to draw a function f first, right? The graph first, then you have to analyze what's happening to the given point. Okay. So we drew a function first, the same problem, right? We are looking at the same problem, this one. So if you draw a function of x cubed minus 1 over x minus 1, you could use the technology, choose whatever you want. You could draw a function graph. So if you draw the graph, the graph looks like a parabola, right? It looks like a parabola. But there's a problem here. You see, there's a hole on this graph. Okay. So if you see somewhere like this, the hole on the function or graph, that means what? At this point, the function value is not known, undefined. So if you have, if you see one hole on the graph, that means function value here, we don't know when x approach to 1. Function is not defined. Okay, here we don't know, right? That is why that's a hole. Function value may not, exist, but the limit value may be there. Okay. So if you look at the graph, this is my x, this is my function value. Y coordinates are my function values, y values. So the x values are here on the x-axis, right? The question is now finding the limiting value of the function fx when x approaches to 1. So 1 is here, right? So you could approach either this direction or that direction. But now you are going to look at along the graph. Remember, if you want to look at the function, the value from the left, that means this is my x value, right? Function is moving like this. Okay, moving like that from all the way to here, right? When you move your x value from left side to the 1, your function is moving from here to there. Okay, moving like that. So function is approaching to this value when x approaches to 1 from the left. Okay, function value means always you have to look at the y value, right? So then what is the y value of this function at this point? Do you see that? What is the y value of this hole?
3.
3. You see here, yes, that is 3. Therefore, the limit value of the function when function approaches, the x value approaches to 1 from the left is 3. What will happen to the right side of 1? So your function is going all the way like that. So if you want to check the function value when x approaches to the right side, so you have to come from this side, So the function is now, the graph is now coming this direction. Okay, earlier it's going up, now coming down. So when x approaches to 1, now your function again reaching to this point. So you have to look at always your curve, right? Again, you are getting 3. So in both the direction, you are getting the same value. That means there's a limit. If you have different values in both the direction, that means there's no limit. Okay, you should have common value in both directions, same value. So this makes sense. Yes, function getting 3 if x approaches 1. That is why we got that answer earlier, right? Numerically and graphically having the same answer. That makes sense?
Yes.
That's very good. Okay, so now these are very good exercise for you too. I think this is not harder. Everything is given. You have to simply plug in these values into your calculator and to make sure that you are getting these all values. Okay. This is very good problem. Have you tried this problem, any one of you?
I have, yes.
Have you got the answer?
I got 1.
You got 1. That's very good. That's good. So let me explain this. Now, remember, we are going to find the limit graphically. That means you need to draw a picture for this function. Okay. So what they are telling that function value is always fixed to 1 when your real value x is not equals to 2. Your function value is 0 if x is 2. So that means your function is getting now 2 different values. These type of functions are called step functions, right? You have several values for particular x values. So if I could draw a picture here, this is x and this is my function fx, y in another word, right? The function value is getting 1. Remember, fx means function, y value, right? The y value, function value is getting 1 when x is not equals to 2. Remember, this is my real line. This is my real line. So 0 is here, say 1 is somewhere here, and 2 is here, and so on. And this side negative 1, negative 2, and so on, right? So here I will get y value 1 and 2, and here negative 1 and negative 2. Okay? So let me draw a graph of these. So now remember, I'm going to draw, the constant value function. Y value is 1. Remember, y is here, 1 is here. So you have to draw a horizontal line which is passes through 1 only when x is not equals to 2, right? Your function should get all the way to 1. But at this point, you cannot make 1. So there should be a hole on your picture. So then you should go all the way like that. Okay, and going like that. Okay, so that is for the first piece. Whatever for the second piece, if x is equals to, if x is 2, function value is supposed to be 0. That means function value is 0. Now you have to define that value. That is just a point, because for this second value, x is getting only one value, which is 2. Therefore, when x is 2, your function should get the value 2. So you have to draw a function like that, the graph of the function, okay? So this is the picture. Now, after drawing a picture will tell you everything, the limit value, okay? What is the question actually? The question is finding the limit of fx when x approaches 2, right? In notation wise, they are asking us to calculate simply limit of fx when x goes to 2. This is the one they are asking us,
I can't wait. That's what you are too.
right?
Buy now and get 2 days free at Walmart. Restrictions apply. What happens to your body language when your underarms are canceled?
Okay, my kind request, everyone, could you put your microphone into off mode? If you have a question, you can switch on.
Underarms cared for and you confident and carefree.
Thank you.
Plastic.
Okay, now this is my graph. So we are taking the value very close to 2. So look at the function and check the value. So when x approaches 2, your function value is getting simply 1. Okay? Therefore, my function value is here when x approaches to 2. Even though function value is at 2 is 0, the limit value of the function is 1. Okay? So you have to understand clearly. Thus, the limits of the function fx when x approaches 2 is 1, but the function evaluated at 2 is 0. No confusion, okay? Two different values now. Function value is 0, but the limiting value of the function when x approaches 2 is 1. Okay, so you may have two different values. One is limiting value, one is the function actual value, right? Limiting value is may not be the same value as your function actual value, may or may not be equal. Okay, no confusion. These two are different things, finding the limit and the finding the actual value of the function. So this is actual value, this is the limiting value, right? Okay, here you could make the table, you know, that is up to you now. You could pick some, you know, close to values, very close values for, you know, -6. Okay, so that is up to you now. You could choose some numbers. So 1, 2, 3, 4, 5, 6, 7. I need 7. So this is my x and this is my function value. So this is your function now. So you have to be very careful when you're plugging the values. Remember, the square root is only for these two terms, okay? Not for the -4. -4 is outside. So if you want, you could put the parentheses like this separately. So when you plugging everything into your calculator, again you have to put a set of parentheses for the numerator and denominator as well. Otherwise you will get the wrong answer, okay? So could you try for these values? -6.1, -6.01, -6.001, and this is the actual value we need to figure out at -6. We don't know, we need to figure out. And from the right side of -6, take a -5.999, then -5.99, then -5.9. Okay, then your task is to complete all the, you know, the blanks and check your answer. If you do correctly, all the numbers here, whatever you are getting, should be very close to what? Correct. Your answer should be -0.125. That is -1/8. Okay. Always try to write down in fraction form exact value. Okay, this is also a very good problem for, you know, you guys to practice. You see now, the Cal 1, the calculus course is kind of, you know, the thing, you have to do a lot of work, you know, so make sure that you are doing plenty of problems to, you know, get practice. Okay, so now these are, you already have been given graphs, and only thing is you need to find out the limiting value, okay? What is the limit value of the function when x approaches 2? 2 is here, right? But remember, they are not asking you to find the function value. We need what? We need the limiting value, limit value. So the graph is here. When x approaches to 2, that means 2 is here. So you have to look at in both directions, right? So you have to check this way and that way. So if you look at these two directions along the curve is here, your function value is getting from all the way to this point and from the right side all the way to this one. Again, the limit value for the function in both the direction approaching to the same value. Therefore, you have the answer, limit answer. So the limiting answer of this point is always here. What is that? Which is 2. Yes. Very easy, no? Limit problem. But what is the actual function value? What is the value of f of 2? The function evaluated at 2 is this value, which is 0. You see? Function value is 0 when x is 2. Function limiting value is 2 when x approaches 2. So two different things, okay? No confusion. Please watch all the videos, okay? So I just want you to watch all the videos on web design, okay? So before going to, you know, complete this, you need to first look at the videos and get some idea. Then you try to finish all the work. Then you have to come for the meeting. You should be good. Right. So the next one, you have the absolute value of x minus 2 over x minus 2 Already we have graph, so no difficulty because graph is there. Okay, this is the catch now. Are you getting same value from the right and left?
They're the same number, but different signs.
That means different values, right? So when x approaches to 2, 2 is here from the right side. When x approaches to 2 from the right side, function is getting this value, which is the 1. Okay. So when x approaches 2 from the right, fx closing to positive 1, right? But when x approaches 2 from the left, the function value fx approach to here, this is from the left. Function value is always y value, that is this value, which is -1. Okay, so from the right you are getting +1, from the left you are getting -1. Two different values. These two are different numbers, right? Different values. So if you want to have a limit answer, you have to have same number, same value for both the direction. But you are not getting same answer, different answer. Therefore, what is your conclusion? Will you get any limit answer for this problem? If you are not getting any limit answer, we call that as does not exist. The limit value does not exist. In short form, we write this as DNE. There's no answer for this problem. That's the meaning. Okay? Okay. You remember this function is now keep on oscillating very close to 0, right? That means what? That means you cannot find one common value when x approaches 0. Right? You see the function value, function oscillating, right? For all the oscillating function at the particular value is always going to be undefined again, because I cannot find one fixed value. Function is keep on, moving, right? At this origin. So function is moving from 1 to -1. So when you have oscillating function, always the limit at that point is going to be, again, does not exist. Okay, this is a little bit hard to understand at your very first time, but when you get, that definition again and again, you should be good. Okay, so this definition says that, okay, there's a typo in my picture. So this should be not C, this should be A. Okay, would you change that to A? Because I have given definition in terms of the real number A, not with C, right? Okay, look at the definition. Let f be a function defined on an open interval, including the point A in real number. R stand for the real number, except possibly at A. Function may or may not be defined at A, but there should be an open interval where the function has its own domain, okay? We say the number L is the limit of f as x approaches to the value A, and we write that this notation is so well known. We already know that. We saw that earlier, right? The limit notation. Limit of fx when x goes to A, if it is L, right? If and only if this is true, if and only if for every epsilon. So you need to read this symbol as one of the Greek letter, right? Epsilon. Epsilon. Okay. So for every epsilon, if you pick any epsilon real number which is positive, then you could find always this guy. This is nothing but delta, because we read this as a delta. Right? If you fix any epsilon positive number, then always you could find one delta, right? This delta is depend on your epsilon. First, if you know epsilon, then you could, find out one delta related to this epsilon. Okay. So if and only for every epsilon, then you could find one delta such that this condition. Okay. How do you read this? 0 less than absolute value of x minus a, right, less than delta. This should give you always the epsilon, right? Epsilon is here. The distance between fx and the limit value is always less than epsilon. Okay. So remember, absolute sign means geometrically, okay, means geometrically the distance. Okay. So suppose if I write like that, the meaning of this is the distance between x and the a. That's what we put epsilon, or the absolute value. So absolute means you are making all into non-negative. Suppose if you have a negative number, absolute will make you always positive, right? So what is the, for example, what is the absolute of -5?
+5.
+5. So this absolute sign always will, change negative into positive. Okay. So in general, absolute x is, okay, x itself, if x is positive or equals 0. Absolute x is negative x if x is less than 0. If your x inside the absolute is negative number, then in order to find the absolute x, you need to put one more negative sign in front of the problem. So this will be now positive. Remember, if x is negative, this guy is negative, I am putting one minus sign in front of negative number. This all will make you the non-negative number. That is why we have two different values for absolute sign. Okay. That means basically absolute means it is geometrically the distance between 2 points. Okay. What I'm trying to say is geometrically, you look at the picture here, right? So this is your function fx graph, right? If you want to find the limit value of this is a here, the limit value of the function when x approaches to a, right? So you are looking at the two different direction, right? So when you approach to a, my function value is getting L. Okay, so you could approach a in both direction from the right side. That means your value is going to move from the, from here to there, L. If you move from the left to a, your function value is moving from here to there. In both direction, when x approaches a, your function value is also approaching to L. Okay, right? That means what? That means the distance between this blue color and this L getting closer and closer when you approach, right? When you approach to this point, to A from the right, okay? Then your function value getting very close to L from the bottom to this direction, that is in yellow color. So if you have this much distance, then you could move, your function value is very close to L when you move your x, from the left to A. So this function is giving kind of idea. So this is nothing but function is just explains, about these geometrical things. Okay. So in another word, what I'm trying to say is if you squeeze these two values into very tiny number, that means you have to squeeze your function value also within that tiny. So remember, these two are very tiny, right? If you make, if you make x very close to a as much as possible, then your function should close to L as much as possible. That's the meaning, right? So this all formal definition, I know this is not easy to understand, but anyway, let's do a couple of problems to get some idea. Right, so let's look at this example. You need to prove that the limit value of the function 8x plus 3 when x approaches 4 is 35. If you're plugging simply 4 to this function, of course, you will get 35, right? When x is getting close to 4, this value is getting 8 times 4, which is 32. Then plus 3 is 35. Yes, this is true. But the thing is, how do you prove? By using your formal definition. So if you want to prove something, the formal definition, we call this formal definition as epsilon delta definition. Okay. So if you are asked to find the limit problem by using epsilon delta definition, that means they mean this. So you need to prove the things according to this definition. Okay. But if you practice, it's going to be very easy. You look at the first problem. You need to prove that the limit of that function is 35. What is the solution? This is the step you need to follow always. Okay. First, what you want to do is you need to identify some things. You compare the given problem into your definition. Okay. So in definition, you see the function f, right? What is the function here in this problem? Could you tell me? What is fx here? Okay, the function is here. This is your function. So your function in this problem is 8x plus 3. Okay. A. What is the x approaches to a? Where's my a here? X approaches to 4 here. Therefore, a is 4. And the limiting value of the function they are telling, which is 35. Okay. So like this, first of all, you need to identify, and after that, you look at this. So you assume that you know the epsilon. Okay. So your job is to now find, the delta. You know epsilon. Epsilon could be any number, any positive number, half, 1/5, whatever you have. You could imagine, you all know that about epsilon. Once you fix the epsilon, you need to figure out the delta. How do you find the delta? This is the step you have to follow. First, you need to find out fx minus L. Okay. You need to always find the connection, find the relationship between x minus A and fx minus L. Okay. So you find the relationship between these two. That's what they are trying to do here. They first started with fx minus L. This is nothing but fx minus L. They are starting to work on with fx minus L. Then they are simplifying fx minus L. This is fx minus L. They are doing some algebra. So simply they are, combining the like terms. So this is constant and 35 also constant. They are combining these two. So plus 3 minus 35 is negative 32. So 8x minus 32. Then they are factoring this and they are writing into 8 times x minus 4. Right? So they started with fx minus L. This is nothing but the absolute value of fx minus L. Remember, my fx is 8x plus 3 and my L is 35. Simply start with fx minus L and all the way simplify. Now this is going to be what? That is going to be my x minus A, right? Absolute. Right? So what they're trying to say, is if you could write fx minus L, which is 8 times as large as x minus 4, that is true, no? Fx minus L is equals to 8 times of x minus 4. So this guy is a big guy, 8 times bigger than x minus 4. Okay. So to make this happen, right? To make this happen, so they are just simply guessing. They are guessing, right? So if you want to make fx minus L to be less than epsilon, want to make that means your x minus 4 absolute should be less than of, if you divide by 8 both sides, you will get all the way what? 8 times x minus 4, right? This is my absolute fx minus L. But if I could write this as epsilon, That means what? If you look at these two now, how can I connect with this one with x minus 4 epsilon? Simply divide by 8 both sides. That means you will get some connection between what? Between x minus 4 and epsilon. Remember, definition says that your x minus 4 should be less than delta. So if you pick this as your delta, you are done now, right? Remember I told you earlier, your delta is always going to be depends on epsilon, right? So now here I am assuming that delta be epsilon over 8, right? Epsilon could be any number. For example, if epsilon is half, right? Then what is your delta? Your delta should be epsilon over 8. Your epsilon is half, so it should be half over 8, which is 1 over 16. So that means what? That means for each epsilon, whatever you fix here, you could find always one corresponding delta. Okay? So these all just to, the theoretical thing. Right. So like this, so you need to figure out first, this is your task, finding the delta in terms of epsilon. Right? Okay, I got now a delta value. That is your task, right? I told you earlier. Try to find out. Try to find out. That's what they're telling here. You see? You need to find out first. So, here, read this. Your job is to find the delta. Right? This all scratch work, finding delta. So now I get some idea. So the delta should be epsilon over 8. Okay, now go back and do the proof. This is the proof. Okay, start with epsilon. Now I am picking my delta as 8 over 8, epsilon over 8. How do you know this? Because of my scratch work. So far we have done all this scratch work. And I figure out that my delta is, epsilon over 8. Therefore, I'm taking my, delta as epsilon over 8 and I'm using my definition. If this is true, then you have to prove that. So your task is to prove fx minus L, which is epsilon. So you need to prove now fx minus L is less than epsilon. That is why they started with fx minus L. Start with fx minus L epsilon, fx minus L absolute, right? Simplify this and show that. Okay. Right? So proof is just 2 lines. But the only thing is, how do you find the delta? For that reason, we need to do this all, the rough work. Okay? So one more time, you can go through your videos there and try to understand epsilon delta definition if you have more, difficulties. And one more time, I will do this. Okay? Is that sounds good? Kind of?
Yes, sir.
Yes. I understand this is not going to be easy, but anyway. Okay, now look at, you are given a picture. What is the task? Finding delta. You need to find delta. What is delta? Do you know epsilon? If you want to find delta, you should know epsilon first. Where's epsilon? If you read the problem, this is the problem, right? Where's the epsilon? Could you find out the epsilon here? Look at your definition and find out. Compare your definition with this notation. Where's the epsilon? Look at your definition.
Isn't the epsilon that 0.1 at the end?
Exactly, very good, very good. Look at this definition in terms of the notation. Fx minus L should be less than epsilon. So if you look at here, fx minus, this should be L, the limit value. 1 is the limit value of the function. This is epsilon. Okay. So what is fx? Fx is the function, original function. Yes, that is 2 minus 1 over x. Our limiting value of the function L is 1. You see 1 here? Then your epsilon is 0.1. You know all three numbers now. What is your task? Oh, do you know A? Do you know the value x approaches? Yes, x approaches to A. This is A. A also 1. You know all four values. What is your task? Your task is to find the delta. If these all four known, then what is your delta value? Simply use the picture, right? Remember, this is the delta I want. Look at here. Remaining all you know. I already told you, x minus 1 absolute means, geometrically, the distance between x and the value 1. This is x. 1 is here. The x could be any number very close to 1. Okay. So what they're telling, they are trying to, enlarge this picture, this square box here. Okay. That means you look at these three values. These three values, nothing but will be somewhere here, because they have enlarged this picture here, right? This black dot is nothing but, the limit value 1 is value. Okay. The function approaches x as 1. Okay. So that means you have, if you join, so it's very hard for you to, if you join this and this point is here, middle point is 1, and the right side of 1 is here. And again, if you draw along function value, the function value is 1, limiting value L is 1. This is my upper value and lower value. Now look at the picture we had here. Same picture now you are getting, right? A is now 1. This is the distance we are looking for, right? The delta. Delta is nothing but this distance, the smallest distance among these two. Okay, this is my epsilon. So this distance from L to this point is epsilon. L to down is again epsilon. A to this side is delta. A to right side distance also delta. Okay, no confusion. Now they are asking us to find this distance. Okay, so your task is to find this tiny distance, right? Now I'm going to find the tiny distance in both directions. No confusion. Okay, there are two tiny distance from 1 along the x value. So your delta is the smallest distance between these two. Your task is to find these two distance. Okay, right? How are you going to find these two distance, or in another word, these two x values? Yes, I could find these two x values, right side and left side of 1. X values can be found by using above and below function value, because you know the fx formula, right? So I already have worked this problem, right? So I'm going to upload today, and please watch what you could look at the answer. Then try to understand. So I'm giving today, you could go through after uploading all the steps, whatever I have given, and it should be good because I have explained everything in words. And your task is to find what? So I'm simply writing here. Your task is to find, okay, delta. For that reason, you need to find these two x values, just below, just left and just right to this point 1. Okay, so then this will be done in my the lecture now. So then after that, so make sure that you understand that. Okay. So now here, we are going to find again the limit of the function, but in different approach. This is called the analytical method. So this is the most common method people use, very easy too. Rather than drawing picture or making table, so this method will give you some kind of shortcut version of finding limits, right? But anyway, we are going to use some theorems or properties, if you want to find the limits of the particular function. Okay, these are very, very basic properties we have. What is the meaning of the first three properties here? The first one is you are finding the limit of the function b. B is the constant function, fixed function. Function value is always fixed, right? Regardless of your x value, function is always fixed. That means if you find the limit value of any constant function, answer is always that constant function. No change in the function, okay? Because function is constant, fixed value. The second one is very easy. The function is simply x. When x goes to c, of course, simply plugging here c, you will get the answer, right? In most of the times, you could simply plugging that limiting x value to the function, then you will get the answer. If you cannot find any real answer, then you have to go for some other techniques to find out the limit. Look at the third properties. What is the limit of x to the power n? N could be any real number, right? N is any positive integer here in this case. If n is any positive integer, what is the limit of the any number to the power positive integer? Simply plugging that the value in place of x. So if x goes to c, c to the power n is my answer. So all three basic properties. Okay. Now here, suppose if you know the two functions limit value, right? You are given two functions now. Suppose if you know the answer for the limit of function f when x goes to c, say that is L. If you know the limit value of the function g when x goes to c, say that is k, then how are you going to find, sorry, how are you going to find, the couple of, different functions? Look at the first two property. You are multiplying some fixed number by a function, then what is the limit of that function? If you find the limit of the multiply with a constant function, answer is always the constant times limit of the function. Limit of the function, we assume that is L, therefore B times L. Simply, this is nothing but simply you just plugging the value into your functions. Then you will get the direct value, right? So these are basic properties. The second one, you know the limit of f and g, L and k, simply plugging L and k here. So you will get that. Same thing here, right? If you have two functions product, simply put the limit value of both functions, L times k. But here, number 4 property is called quotient property. If you know the limit of two functions already, then what is the limit of the, the ratio of those two functions? Simply divide them. This answer will be true provided k is non-zero number. Your denominator should be non-zero number. If your denominator is 0, then you cannot write the answer, okay? If your function value is L, then what is the limiting function of the power n? Simply plugging L there and L to the power n. These are all fundamental properties of limits. So you should be able to do this within a minute. What is the limiting value of this function? Simply plugging x, x goes to 2. That means simply plugging 2 here. So what is the answer? So what is that? 24, right? So what is here? The second problem. When x goes to 2, you will get 2, 3 minus 2 times 2, 2 times 2, yes, then 2 plus 1. What's that? 2 to the power 3 is 8. 8 minus 4 is 4 over 3, right? Okay. So now this one is about finding the limit of the polynomial. Polynomial is what? Polynomial is the, the expression. You could write the general polynomial function as like, a naught plus a1x plus a2x squared plus a3x cubed and all the way going to an x to the power n. So this is the general formula for the polynomial with the degree of n. Okay, this n can be any number, any positive n is positive integer. So if you have this kind of form in the function, that is called the polynomial function. If you have polynomial function limit is nothing but simply plugging the c value into that function. So you will get that, like earlier we did. Okay, earlier we did here. Remember this example one, go back. This is now polynomial, right? 5x squared plus 2x is a polynomial with the degree 2. So if you have a polynomial, what is the limit of x goes to 2? Simply we plug in 2. That's what we did that there, like that. Okay. So now second property says that suppose if you want to find, suppose if you are given two polynomials, remember here, if R is a rational function given by Px over Qx, okay, so where Px and Qx are polynomials, so two polynomial functions are given, but you are taking the division, you are dividing Px by Qx. Then what is the, the limit value, right? Again, like earlier we had that, fx over gx here, the same type of property. Okay, so there you have to divide, 2 and simply plugging, the x values, the x values into the polynomial and divide. So this answer should be true provided QC is a non-zero number. Then only you could write like this. If QZ is 0, then you cannot write your answer in this form. That's not correct. Okay, look at these examples now. Yes, you have two polynomials you are dividing, okay? So how do you find the limit? Simply plugging 1 in the numerator and the denominator as well. Remember, your denominator should not be 0. Yes, if x goes to 1, 1 plus 1 is 2, non-zero number. You are good here as well. If x goes to 2, 2 plus 1 is 3. So it is a good number. So simply plugging the values. So simply plugging 1 for x. So you get 1, 3 minus 2 times 1 plus 1 over 1 plus 1. Simplify this and write down. So it should be 1120 over 2, right? Which is 0. So here simply plugging 2. So which would be 2 cubed plus 2 squared plus 1 over 2 plus 1. So that's give you 8 plus 4, 12 plus 1, 13 over 3, right? Okay. Finding limits getting easier and easier. These are all basics. So now one more thing. Again, so simply plugging C into that x value. But this is true only, right? Read this. The limit of a function involving with the radical, if you have the square root kind of, for example, if you have square root, cubic root, then how do you find the limit of those functions? Simply follow this, the pattern. Let n be a positive integer. Your n should be a positive integer. The limit below is valid for C when n is odd. Okay, so this is true when, right, n is odd, and it is valid for C which is bigger than 0 when n is even. So you have basically two different cases based on your C value. If your C is any kind of number, then n should be an odd number, right? For example, you could think of like this. Problem may be finding the limit of, say, x going to, say, -3. Okay, so what is the limit of x, say, n is, say, n is 5. So your problem will be like this. So your limiting function could be negative inside the radical. If you have negative inside the radical, then outside the root, n should be always odd number, right? So you cannot put negative number for even, you know, the radical root power, right? For example, you cannot write down like this. This is not correct. Limit x goes to -2 of square root of x. Would you find the limit now? Now it is not possible, right? Square root means here I have 2. 2 is an even number. For even number, you cannot have negative. C cannot be negative because I can't find the negative of square root. That's not true, right? So therefore, you cannot find like this limit. That is why you always have two different cases. One is for all C and another one is for C bigger than 0. If your C is bigger than 0, then only you could find for even. Okay? So, but anyway, when you plugging the values, you will come to know, right? So now next one is about if you know the limit of two different functions, gx and fx, okay? If you know f and g are functions such that the limit of gx is L and the limit of x goes to the same value of the function is f of L, then the composition function. Are you good with composition function? Have you seen composition function here before? I believe most of you have taken pre-cal and maybe algebra, college algebra, right? There you might have seen that the composition function. You are combining two functions. Okay. If you combine two functions, the limit of the composition of two functions always simply again plugging the limits of the function value, right? This is theoretical things, but if you look at here, simply you plugging a x value inside the radical. Remember, it should satisfy, if you have the radical, it should satisfy like this earlier conditions, right? If you have negative number inside the radical, make sure that you have here what? Odd number, not the even. Okay? If you have inside a positive, then doesn't matter. You could have here odd or even. Right? For example, can I find the limit of this problem? In another word, could you find the limit of this function? What is the limit? Simply plugging -1 inside. What you will get? Cubic root -1 squared plus 5 times -1. Remember, this is cubic root. Could you simplify inside? What you'll get? Is that possible to find the cubic root of -4? Yes, it is possible because 3 is an odd number, so no problem. Regardless of inside the sign, you will have always, answer for this. So this is the answer for that. But here again, if you're plugging 0 inside the radical, 2 times 0 squared plus 8. Yes, it is simply square root 8. Next, move to the trigonometric functions. So you are familiar with the trig functions in pre-cal or trigonometry. So now, again, if you find the limit value of the function where x goes to some x approaches to some values which are in the domain of the given function, make sure that these values c are in the domain of the corresponding trig functions, right? So at this point you all should know how to find the domain of the trigonometric function. Okay, please go over your trig and maybe pre-cal notes, okay? Right? To find out the domain. Domain of a trig function, trigonometric functions. Okay? So your C should be the limit value, the x should approach to the domain point where which is domain of your corresponding trig function, right? Again, the result are like earlier, same, simply plugging the x value instead of the function value. So sine x when x goes to c is sine c, right? Cosine c, tangent c. Simply replace x by c. Very simple, right? Okay, so now you should know the unit circle, the trig values of the the 6 functions you learn: sine, cosine, tangent, secant, cosecant, and cotangent values. Okay. So now you are going to tell me what is the limit of cosine x when x approaches to pi. Who is going to tell me? Simply replace x by pi here. So you will get simply cosine pi. What is cosine pi? Cosine pi is -1, or remember your unit circle. The next one is going to be limit, x goes to 0, simply plugging 0 into the function, sine squared 0. Sine of any number 0 is 0, therefore sine 0 is 0, so therefore which is 0. So the next one is going to be tangent pi over 4. What is tangent pi over 4? Yes?
Isn't that the sine of pi over 4 of the cosine of pi over 4?
Which is?
So that's square root of 2 over 2 over the square root of 2 over 2.
Okay,
So 1.
that 1. That is 1. Okay, good. So the next one, simply plugging 2 times x is now pi over 2. What is that? When you simplify, 2 times pi over 2 will be just pi. Again, cosine pi is -1. Very easy, no? You know trig values. Okay? So this is all about the trig values, function limiting values. Okay, so far we are good. Simply be plugging into the value, plugging into the function, right? For particular x value. But there are some cases you will not find the answer. For example, look at this one. Could you find the limit of this function now? X goes to 1. What will happen if you're plugging 1 into this function now? Now we are in trouble, right? When x goes to 1, now I cannot simply plugging 1 like earlier we did. Why it is? You will not get good number in the denominator, am I right?
Yeah, you'll get 0.
0. What about in the numerator? Numerator also will give you the same answer, right? 0. Right? When x goes to 1, 1 cube is just 1. 1 minus 1 is 0 over 0. What is that? 0 over 0. Can I find any real value? No. This is called indeterminate. Okay, indeterminate value form. So if you have 0 over 0 form, when you do the limit problem, that means you are not succeed. You need to have some other techniques to find the limit, right? So you cannot directly plugging the values like we did just now, because these are different problems. Now for this type of problem, we can do like this like earlier. Now you need to use some techniques. What kind of techniques we are going to use? Well, there are plenty of techniques. Now we are going to look at one by one, okay? So if you look at this note, in many cases, one can evaluate the function value simply plugging into function as x is a. In some cases, we need to have some strategies to evaluate the limit. These includes dividing out technique, division, long division algorithms you studied, right? Or some other rationalizing, technique. I'm going to show you 2 different techniques to do these 2 problems because we are getting 0 over 0. Okay, these kind of techniques can be used only when you have this kind of scenario, 0 over 0 or infinity over infinity. So if you cannot find good number, then we are going to look at some other technique. Okay, so at this point, I would like to tell you the scenario where you get 0 over 0. Okay, What is the technique I'm going to use? I'm going to use the long division. Let us simplify this guy. We are going to simplify, okay? Simplify this all expression. How? By using the long division, right? Remember, this is a fraction. Numerator is x cubed minus 1. You are dividing by x minus 1. So like a number, I'm going to divide by using the long division. Do you know already about the long division? Say yes or no.
I remember learning about it. I would have to brush up on it again.
Okay, very good. So you need to refresh your, basic things. Okay, anyway, I'm going to do here. So I'm going to divide x cube minus 1. That is my numerator you have to put inside. And you are going to divide that guy by what? So that guy by x minus 1. Right? The divisor is here, the dividend here. Okay, I'm going to divide. This is the way. Look at the power here. Power is 3. Here power is 1. So I'm going to put the quotient here. So in order to make, you are putting some polynomial here. When you multiply this number with that, you should get the inside. So in order to get x cube here, you already have x1 here. I need to put here x squared. If I put here x squared, when you multiply these two, you need to multiply, okay? Simply multiply this and with this highest degree, then you should get this degree, okay? So when you multiply x squared times x, then you will get x cubed, right? Then you have to multiply x squared with -1, then you will get -1 x squared, okay? That is negative x squared. What I'm doing, I'm simply distributing, multiplying x squared with x one time, then x squared with -1. Okay? Then you need to subtract like a long division, right? You know all about long division. Simply subtract these two guys. When you subtract x cube gone. Okay? When you subtract these two, you are subtracting, right? Then this will be, you have to switch the sign when you subtract. So this will be x squared minus 1. So you are subtracting like this. You have -1. I'm doing here and explain. Then you are subtracting this guy. This is negative x squared. So when you multiply with the negative sign, you will get plus x squared. So that is nothing but x squared minus 1. Okay. After subtracting, now again you have to check. In order to get x squared inside, I already have x here. What should I put? I need to put here x, no? If you put x, when you multiply x with again x minus 1, x with x, which is x squared, then minus x with 1, which is just x. Again subtract. Now when you subtract, again the same guys vanish. Now when you subtract -1, subtract negative x, then you will get x minus 1. Got it? Now you have here x minus 1. Here also I have x minus 1. Therefore, you have to put the constant value here, just 1. So you need to put there 1. Okay. So then 1 times anything here you have, you will get the same one. So remember, when you do the the division, if you have a good number, you have to have 0 here. This is my reminder. This is my caution, no? Make sense? Remember, when you divide one number by another, if you get the remainder 0, that means what? That means you could divide the given numerator by the denominator without any remainder, right? That means answer is nothing but just quotient, okay? So when you divide this, limit x goes to 1. So when you divide this, answer is nothing but just a quotient. Only write the quotient when you have the remainder. So answer is simply x squared plus x plus 1. Does that make sense? Simply I am dividing. That's it. So if you are not sure about this, you can go through and check your previous, the notes, college algebra, pre-cal, and those things. You will come across long division, polynomial divisions. Now, problem is very easy, no? You have now just a polynomial. Now simply you plugging 1 here, you will get good number. Now if you plugging 1, you will get 1 squared plus 1 plus 1, which is 3. Okay, so make sure that this long division is, refer the things about the long division. Okay, so let me know if you have trouble in long division, then another meeting I will just go through some more problems. Okay, that is one way, using the long division and making the given expression into different form, then you should be get good number. In another one, you could use the factorization, right? So this is, when you see the quadratic expression in numerator, it is always easier to, factorization. So do you know how to factoring? Yeah, you might have seen this in high school, right? Factorization of, the quadratic expression. So if you factor these, you should get what? When you distribute, you should get back to the original one. You will get. Please check. You have now more work to refresh your mind. Right, so what I'm trying to do is I'm trying to write down in the numerator part in terms of factoring. Yes, I could factor this guy by simply x plus 4 times x minus 3, right? This is only for the numerator, but I already have the denominator, which is x plus 4. Okay, so you have multiplication, notation here. So it is very easy. You are simplifying here. Remember, this is like a real numbers, right? Numbers. If you have same guys from numerator and the denominator within the multiplication sign, simply you could cancel those two, right? That means you will come up with simply x minus 3. So the problem is now very simple. When x goes to negative 4, now your answer is x minus 3. Now easy. Simply plugging here negative 4. The answer is negative 4, negative 3 is negative 7. Now again one more theorem. This is very, very useful theorem, which is a squeeze theorem. Squeeze theorem says, the very little fundamental thing. What is that? Suppose if you have, one function fx, which is bounded by two functions, one from left side and one from right side. Okay. One function fx is now, right, bounded by two functions, within two functions. Suppose if we know the answer of these two bounded functions, then automatically middle function also will go to the same value whatever we have here, right? Suppose if you know the limit of x goes to c of hx and the limit of x goes to c of gx, if you have same answer for these two functions, say answer of this guy is say L, say answer of this guy is L, that means what? If you have the same answer for left and right, that means your middle, function limit also should approach to that same value L. In another word, the middle function is now squeezed. It is squeezed by these two guys, right? So when you squeeze like this, and the function will go with that same value, will agree with the same value, whatever, these two functions getting. Did you get the idea? That's called the squeeze. Right? Only thing is you should have same value for these two left and right functions. Then only the middle function will go to the same value. Okay. So we will, come across some, some problems later by using the squeeze theorem. Okay. So now keep in mind these two very, 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 very useful results. These two guys came from the squeeze theorem, but only thing is you should know only, the result. You don't need to know the proof, only result. Okay. These two are very, very basic, at the same time, very, very important to limit properties. Limit of sine x over x when x goes to 0 is always 1. Can I find the limit of x0 by using the previous methods? Can I simply plug 0 here to the function? You will not get any answer, because if you plug in 0 into sine x, sine 0 over 0, sine 0 is 0 over 0. Again, you see, you are in trouble. You are getting indeterminate form. Therefore, you cannot find the limit using the basic properties we have studied so far, right? For that reason, we used some other, ways to find out the limit. Actually, we use the squeeze theorem, but the result says what? The limit of sine x over x is always 1. The second result is the limit of 1 minus cosine x over x when x goes to 0 is always 0. So you could directly use these two results to, do some other problems. Look at the first one. Could you find the limit of tan x over x? Okay, I'm doing like this. Limit x goes to 0. Remember, tan means sine over cosine. So I could write down tan x as sine x over cosine x. That is for tangent x, but I already have x in the denominator, right? Now you need to play a little bit around. So you need to rearrange this. Remember, I could rewrite this as sine x, right, times 1 over cosine x, this all over x. Because when you multiply, you will get back again sine x over cosine x. Now what is this? This is limit x goes to 0 of sine x over x times 1 over cosine x, right? Now remember, you could think of this is one function and this is another function. You are going to find the limit of two different functions with the product. Remember the properties we learned earlier? If you want to find the limit of the product function, that is always going to be the product of the limit functions. In another word, you could split the limit into two pieces if you have, the product. Okay, so let me write down the answer somewhere here. I don't have space. So the limit of sine x over x times 1 over cosine x when x goes to 0 could be written as, I'm splitting limit into two pieces like this. You could do that, right? You could split for product, for plus sign, or for minus sign, whatever. You could write down like this. No? Now you could find the limit for these two separately. What is the limit of first piece? Could you tell me the answer? Limit x goes to 0 of sine x over x. What is that?
That's 1.
That's 1 by using the properties, just, So there is just 1. This piece is now easy. What is the limit of 1 over cosine x when x goes to 0? Yes? That is easy now. 1 over cosine 0. What is cosine 0?
That's also 1.
That is also 1. So that is 1 times 1 over 1, which is 1. Easy. You see now? So you need to play around a little. We need a lot of smart work in Cal 1 and Cal 2. Changing everything, writing in different ways, and using all the blah blah whatever you have, the basic properties. You have to use everything now. Okay. For that reason, we need to have a lot of practice problems doing, right? Okay. Look at the second one. You need to play around a little bit. You need to have you smart a little bit. How do you approach this problem? Number 2. The question is finding limit t goes to 0 of sine 3t over 2t. If you want to use the previous properties, you have to have same variable x here and there. But now, unfortunately, you have t here, but here I have 3t, two different things, right? What will happen if you could write like this? I'm going to rewrite this as, right? If t goes to 0, means 3t also should goes to 0. Am I right? Same thing, no? If t goes to 0, what will happen to 3t then? 3 times 0 is 0, right? That means writing t goes to 0 is equivalent into 3t is goes to 0. I could do that. So now sine 3t is there. Let me write down 2t as like this. 2 times, I'm writing like this. Do you agree with me? You could rewrite 2t as 2 times 3 over 3 times t. When you simplify back, you will get again 2t, right? Because 3 cancel, you will get simply t here. T times 2 is 2t. Am I right? Now what I'm going to do is, I'm going to, separate. I'm going to separate the constant piece. 2/3. Okay? So if you move that, and you could rewrite this as a limit 3t goes to 0 sine 3t over 3t. I'm writing this 3t here. Then times, I'm writing the constant 3 over 2 separately. Okay? That is there. Now problem is very easy. Remember, we had the properties of limits. If you have constant times function, the limit is simply you have to plugging into the the function. The constant is still same. So the answer is what? Simply 3 over 2 is constant I'm writing. Now write the limit 3t goes to 0 sine 3t over 3t. Now let 3t be some value x. I'm going to substitute, 3t by one another variable, new. I'm introducing new variable, say x. My x is here 3t. If you replace 3t by x, now problem is nothing but 3 over 2. Limit x goes to 0 of sine x over x. Now we are good. What is the answer of this piece? Sine x over x, x goes to 0. Yes, that is 1. So answer is 3 over 2 times 1, which is 3 over 2. So we had kind of smart work here, right? Writing down the given problem in different way and bringing those properties, whatever we have here. You see? Once you know the technique, then again and again we are going to use the same thing, right? When you see first time, it's kind of weird, but after getting into practice, now you should be good. If you see like this problem, different numbers in the numerator and denominator, you have to play around like this. Okay, any questions so far? Are you okay, guys?
Calculus is just a different thing.
Yes, exactly. We need to have more work now, you see that?
Yeah, I could do with more practice.
Exactly. So yeah, practice makes perfect. So we have plenty of time now, and so yeah, you should be good, because after doing all the web design, and web design will make you good progress, because it will give you a lot of exercises. Okay, right. Again, we have more work here for the number 4. Why don't you think about number 4? Again, I will upload the answer. You will see the answer, but I just want you to try first. Let me give some hints for that. What you want to do is you have to split and rewrite the given problem by using these two properties. Okay, use those two properties and rewrite the problem in connecting these two. Then you have to split the limit into two pieces and check whether you are getting. You should be good. Okay. Right. Some of you today asked two couple of problems from your web design. Who is that? So these are the problems, right? You had. We need to have a little bit, high school things to do this problem. So you already have seen. Let me recall before going to do this problem. Have you seen these binomial expansion of a plus b whole thing squared?
Yes, sir.
Use this expression of a plus b whole thing squared. We are here, right? Okay, you need to find the limit. Don't be scared by looking at your notation. So this is nothing but delta x is just a number like x, right? Like just a number. So delta x is a real number. So they use a weird notation, but don't be scared. This is just a real number like x goes to 0. Do you understand?
Mhm.
Okay. Only thing is now you have to find the limiting value of the given huge expression. Your expression is now very, very big, right? So
Right.
this is the expression. So let me copy down the problem first. 7 times x plus delta x. This is also delta x. We have to read like this. And plus 7 minus of x squared minus 7x plus 7. This all over. Okay, Sharon, could you tell me from which section you are doing this problem?
This is 1.3.
1.3. Okay. Okay, so now what is your task? Your task is to find delta x goes to 0. Okay, let me ask one question. What will happen if you plugging delta x 0 right away here? Will you get any answer if you plugging delta x 0? No, you will not get. Look at here. What will happen if delta x is 0? Simply plugging 0 wherever you have delta x. Okay. So let's do that. What will happen if delta x is 0? If you're plugging that into here, what is the answer you will get in numerator? Could you tell me? When delta x 0?
Well, you can't divide by 0.
Exactly, because you will have here 0. And if you simplify here as well, you will get 0. Then you will get 0 over 0 form. Like again, unsuccessful, right? Because this is not good. That is why we need to have some other technique. What is that? Using the expansions and simplifying. And after that, we will check whether we could find a good number. Of course, you should get. So my task is to simplify the numerator. So let us simplify our numerator. So I'm going to simplify this. Okay, I'm going to use this expression, whatever I have written just now. I'm going to use this one where to the first expression, to this piece. If you compare these two now, in place of A, we have X. In place of B, you have delta X. Do you see that?
Yes, sir.
Yes. Then let us distribute that then. Okay. Let us copy down this. A is now X. So if you expand this, you should get what? X squared plus 2 times A is now X times B is now delta X. Am I right? Plus, you should get B squared. Your B is now delta X, but squared. So these are the three terms you will have when you expand your first term here. Okay? Then distribute with a -7, these two guys. You have to multiply out with these two, with 7. So -7 times x is -7x. You need to distribute minus sign with plus sign. Minus into plus is minus 7 times delta x. I am simply distributing. Then I have plus 7 outside, write it down. Again, you need to distribute with a negative sign inside. All three should be multiplied. So you should get negative x squared, negative into negative, this will make positive 7x. And again, minus into plus is minus 7. This is the huge expression you will have in the numerator. In the denominator, of course, we have just delta x. Now what are we going to do? We are going to simplify the numerator piece. There are a lot of terms going away. What are the terms going to vanish?
I see that your 7s go away.
What about x squared?
The x squares do go away.
Yes, plus x squared minus x squared gone.
Your 7x's go away.
What else?
Your
Plus 7 and minus 7 gone.
yes.
That's it, right? Anything else?
Don't yeah.
Yeah, that's it. Remember, this is multiplication time. 7 times delta x. So the leftover, pieces are here 2x times delta x. Then here I have plus delta x squared gone. Again, here I have negative 7 times delta x. That's all, remaining all gone, right? This all over delta x. Now look at the numerator part again. Delta x is the common factor. You have delta x everywhere, here, here, and there. That means you could take delta x as a common factor in the numerator expression. So let me pull out that delta x as a common factor. You all know, the factoring, right? Factoring, the number in the expression. So I am pulling out delta x everywhere. So if you pull out delta x, you will get here simply 2x. But here you have delta x squared. Delta x squared means no confusion, okay? Delta x times delta x. You already have pulled one delta x outside, therefore you have one more delta x inside. Minus this delta x already have pulled out as a common factor, therefore you will have simply 7 there.
Yeah, I got this far when I first started out in the homework, but then I wasn't quite sure what to do after that.
Okay, very good. Now, remember I told you delta x is just a number. You see now here, you are multiplying and you have same number. You could simply simplify. Just cut those two, go away. Does that make sense?
Yes, sir.
Okay, now you see the answer.
Yes.
We get just 2x plus delta x and minus 7. When delta x goes to 0, this guy is gone, 0. Then remaining is going to be 2x minus 7. Do you see now answer? Very good problem, no? To practice. Okay? Okay, now again, you need to find the limit with the delta x, but you are given the function. Now you have more work than the previous one. Because in the previous one, you already have the expression. Now you have to write down everything. Okay, so your function is now fx. Your function fx is now 1 over x plus 9. Okay, you need to find the limit for what? You need to find the limit for delta x goes to 0 of f of x plus delta x subtracting fx. Then you are dividing these all by delta x. Now the thing is, you need to find out now f of x plus delta x and this expression. You know the function fx now, 1 over x plus 9. Okay, now tell me, if fx is 1 over x plus 9, then what is f of x plus delta x? How do you find this guy? You know fx is 1 over x plus 9, right? Then how do you find f of x plus delta x? It's very simple. Simply replace x by x plus delta x everywhere here. Okay, so simply to get this guy, okay, I'm writing here, simply replace x by x plus delta x. Where? In the equation, right? So let me call that as 1.
So do you still keep the 9?
Yes.
Okay.
Right? Simply replace x by delta x into your fx function. Then you will get x plus delta x. Okay? That means take the function. So you are going to replace x by x plus delta x, but you have 9 also. So that is simply plus 9. So your f of x plus delta x is simply 1 over x plus delta x plus 9. That's it. Now problem is easy. Now go back and find out. So limit delta x goes to 0. I'm writing down the expression. You need to now find out this guy. Okay. Already we know now f of x plus delta x is here. So this is my f of x plus delta. I'm replacing f of x plus delta x by this guy. Then subtract f of x. F of x is here, simply 1 over x plus 9. This is f of x plus delta x. This is f of x. This all over, you need to divide by delta x. So I am simply copying here. Now what is your task? Your task is to simplify this and find out the answer. Okay. So we need now a little bit algebra to do from this point. Remember, you need to combine these two fractions. You learned how to combine two algebraic expressions, fractions. You need to find the LCM of the denominator, right? Right. So let me write down here. If you combine these two fractions, the LCM of the denominator is simply the product of these two. Simply the product of these two. I'm simply using your high school mathematics. That's it. So remember, when you combine these two, you have to cross multiply, right? This guy with that and this guy with that. Okay. This all only for the numerator, right? But I have already delta x in the in the denominator. Okay. So you need to simplify further. So this will be limit delta x goes to 0. So let us simplify here in the numerator. So you need to, distribute with the negative sign inside. Distribute with the negative sign with all three, numbers. So you will have what do you have? You have now x plus 9 is here. Then minus into x is minus x. Then minus delta x. Then minus into plus again minus 9. Okay. So this is just my numerator. Over this denominator will go with this denominator and get multiplied. So these are basic properties of fractions, right? Okay, and let us simplify further. What are the terms going to be cancelled in the numerator? Then you will get only what? Negative delta x. The numerator. The denominator says delta x times x plus delta x plus 9 times x plus 9. Right? Now you could cancel these two because you are multiplying. So that means the numerator is nothing but negative 1. This is limit x goes to delta x goes to 0. You will get just negative 1 over x plus delta x plus 9 times x plus 9. That's it. Now you'll get the answer. You see the answer now. When delta x goes to 0, this guy getting 0. Then what is the answer? Do you see that?